So now, table shows the world population growing at a rapid rate. We want to identify independent and dependent variables and then make a scatter plot to determine what relationship, if any, exists in the data. Okay, there's already some relationship here, isn't there? Okay, what's the relationship? Right, but more importantly, that for in 1650 there was what? Okay, so that's a relationship, isn't it? Okay, which one's independent, which one's dependent?
Okay, year is independent.
Very good. Why is that important to determine those?
Because we're trying to look on the axis.
Okay, so if we're independent, then we're going to go ahead and I'm going to graph it, and it's an independent variable. I'm going to go ahead and put it on the x-axis right here. Okay. By default, by rule, that makes my other column, right side, the dependent, and that's going to go on the left-hand side or on the vertical axis. Okay. So now all we need to do is just plot the points. Since I know or determined that the relationship is here, I go to 1650. Look out. Go to 1650 and then go up to how much? Yes, ma'am. Okay. Okay, so plot a point. 1650 is going to be 1600 be right in the middle, and about right there, and then go up halfway, right? Plot a point. Then my next point, 1850, 1800, then it goes up to 1000. Okay, 1930, a little bit over that, and then up to 2000. 1975, 4,000, you got right here. Okay, 2004, 2000 be a little over, so 6,400. Maybe right in there. Okay, so now there's your scatter plot. Basically, if I want to draw a line of fit through that, I want to get as closer to the middle as I could possibly get here. All right? So a line of fit would look like that. Okay, you guys draw that through there. I don't know if that's on your list. Draw your line of fit. It's going to be right through here. Okay. Next thing we need to do is we want to write the slope-intercept form of an equation for that line of fit that we just did. Okay. Now you notice, where did my line start? Started in the middle of what? The x-axis. What if I continue this line all the way down? Where's my y-intercept going to be? It'll be a positive or negative? Okay. So now I'll come back to my equation. We're going to have 2 points. I'm going to use the 2 points that I use on the table. I'm going to use this one right here. Whoops. I'm going to use this point right here, and then probably this last point right here. Okay? This would be my x of 1, y of 1. This would be my what? Y of 2. Yeah. So we go back to here. X of 1, y of 1. X of 2, y of 2. Okay, so 6,400 minus what? This. And then 2004 minus what? What's that gonna be? 5,400? Over what? Okay, now, what I use this as my slope?
No.
Somebody tell me why. It's a huge number, isn't it? What do you think we should probably do at this point? Okay, what we talked about this a little bit earlier. Ideally, I would like to get the bottom number to be what? 1, right? How do I do that? You take the top number, divide it by the what? Bottom number. What would that be? 75?
35.
35.1. Do I need to put 0.1? No. Because listen, this is a what? Scatter plot. Okay? I can round a little bit and approximate here. Is everybody clear on that? Okay, so I'm just going to say 35 over 1, or basically just 35 will be my slope. Okay, now pick a point. Which one? Let's go ahead and use the one that I labeled the first point. So y minus what? 1,000, good, equals x minus, okay? Now I just need to simplify, because we've got to write it in slope-intercept form. So y minus 1,000, 35x, 35 times negative would be what?
64,750.
Then what? Add 1,000. What's that end up giving me? No. Should be 63, shouldn't it? 750. Okay, now, does that, my equation, based on what we just talked about, does that look reasonable? What did we just talk about? What did we say, first of all, about our V, or y-intercept? What did we say? What is going to be where? If I draw a line of fit through here, it's going to continue way down here, right? So my y-intercept, should it be positive or negative? Okay, so the y-intercept that I have in the equation that I just wrote, does it look like it's about where it should be? Yeah. Is everybody clear on that? The other thing is it a positive correlation or is it a negative correlation? Am I ever going up or is it going down? It's going up, isn't it?
Yeah.
Okay, so my slope should be positive, right? Is my slope positive here? Okay. So I'm probably in pretty good shape there, right? Give or take a few numbers, few points. Everybody with me? Okay. Interpolation or extrapolation do the same thing, okay? The table, now they have a lot of these on the EOI tests, okay? A lot of them. The table, you gotta go to the office real quick. Sorry. The table and graph show the world population growing at a rapid rate. Use the equation y equals 35.1x. Does that look familiar?
Yeah.
Isn't that what we just came up with? We just didn't use the 0.1, did we? Okay? So it's basically pretty close to the equation that we just came up with. And I want to predict what? World's population in. Okay, so now, what column over here is this? This column right here is what? It's X, isn't it? Hey, Dominic, see who that is on my phone. We said that this column is X, right? We said this is our year, okay?
It went away.
So this is going to be, who was it?
It went away.
Oh, is your name on there? So what is this going to be? X. So if I have my equation here, what can I do with this?
Put it in there.
Yeah, put it in for, that's the interpolation. So y equals 35.1 times that end up giving me?
71,771.
77?
Zero put the
Okay, I'm not gonna put 5.5. What that end up being?
71, 14.5.
71,
14.
42. Okay, now, we have to understand that this is in what? Millions. Okay, so this should be 7,142 what? That's one right. Guys, see that? How we're doing that? Anybody have any questions on that? Okay, example 3. Is this one in your book? Okay, now, I think one of the reasons why I put this in there is because on the EOY test, okay, they, instead of putting their tables like vertically, okay, they like to do them horizontally. Does this change anything about your data? No? Okay, the top column or the top row is gonna be what? X, that's my independent. Dependent is gonna be the bottom one, right? So instead of my order pair being left and right, they're gonna be up and down, right? So my first order, this is gonna be X1, Y1, so on and so forth. Does everybody see that? Okay. So again, if I want to write an equation, I need to pick a couple points to do my slope. What could I use? I like to go either at the beginning and then somewhere like right in here. Make that X2 and Y2. Okay. So like these two right here, you can go those two. I mean, you can even do the one at the end and the one in the front. Okay, so I've got 1165 minus 1051, 8 minus 2. Somebody do this for me on the calculator.
One 14.
114 divided by or over 6. Reduce that to be 15. 19. Okay, so I'm gonna put 19 there. I'm gonna use 1051 there. And then X minus 2. 19X, and then that'll be 8, 1, 2, 38. Did I do that right? Okay, then add that. X plus what? No. Opposite signs, right?
Yeah.
10, 13. Okay, now look at your graph. Look at this little box over here. Did everybody see that? Okay, does my y-intercept look reasonable? If I were to draw a line of fit through here, it's gonna go like right through there.
Yeah.
Okay, so we're probably in the ballpark, maybe a little high, right? But we're still pretty close, right? Okay, the thing about this with scatter plots is your data is gonna do what? It's gonna fluctuate some, okay? So you have to be ready to be able to give or take a little bit or approximate, all right? My slope is positive though, isn't it? What's my line do?
Fine.
Okay, so it's a positive correlation, right? All right. So I think we're in pretty good shape there. There's a CYP if you want to write it down. Have you got all these notes? You might want to pay attention to what we're doing. Guys got it? Come on, you good? Okay, pair check. Find your pair check. Okay, so the first thing I want us to do is what? Draw a scatter plot. So I'm just gonna plot my points. What's my y-intercept here? Anybody tell me what the y-intercept is? Huh? Yeah, but what's the actual point? Where's this line gonna intersect the y-axis here? Yeah, right here, isn't it? How do I know that? Because this is what? What have we always said about the y-intercept? It has an x-coordinate of what? 0. Everybody with me? Okay, so I'm gonna plot a point just a little bit above 5. And then 1 and 5.39 will go where? Right below the 5.4. And then 2 and 5.66, which probably just be a little bit over that line. 3 and 581, a little bit over that line. Then 4, 603, right there. What kind of correlation do we have? Positive, good. My line of fit probably right in there, pretty close to them, maybe a little off. Okay, so I can, with a reasonable doubt, I can predict that, you know, in 2010, what's going to happen to the admission price? It's going to go up, isn't it? What do you think is going to happen in 2020? 4 more years. We're going to go up any more, right? As long as the correlation does what? That is positive. Now, is there some other things that may come into play there?
Bad movies.
Bad movies, well, but what if the market falls? What if the market crashes? What if gas prices go back up or stay down? Could that affect things? You know, the gas prices right now, dropping down, what have they done? They've affected a lot of things, haven't they? What happened when gas prices were way high? Everything cost a lot more, didn't it? Okay, because what do? You have to transport goods across country, don't you? Well, that costs a lot of money to do that, doesn't it? Okay, so they have to recoup their costs somehow. They do that through the consumer, right? You guys buying products, that's what happens. Okay, so draw a line of fit. We did that on the previous problem. Can I make an equation for that line? Okay, what points do you guys want to use? I'd use the 0 and 508, 4 and what? What was it, 60?
6.02.
Okay, so x of 1, y of 1. Okay, so 603 minus 5.08. Now, let me ask you a question. Let's see if anybody's done this. Do I have to say 603? It's close enough to 6. I could probably just say what? 6, couldn't I? Could I just say 5 here on this one?
5.1.
I can just say 5, couldn't I? So 6 minus 5, 4 minus 0. What would that be? 1 over 4. Okay, so for every 4 squares we go up, we're going to go right. How many? Oh, wait, that's wrong. For every 1 square we go up, we go right. How many? 4. Okay, so y minus what? 5. 1/4 x minus 0. Okay, so y minus 5 equals 1/4 x. What is this times that? 0, right? Positive or negative? It doesn't matter. Yeah. Okay, so add 5.
Y squared X.
But in actuality, you guys know that it's not just 5 though, it's what? 5 point. Isn't it? Okay?
Oh, yeah.
Yeah, remember? That's what we said, right? Okay. Everybody good? Is there one more?
Yeah.
Positive, negative, no correlation.
Positive.
Positive, very good. That's pretty easy, isn't it? That line's going up. So as time passes, the more I exercise, what happens?
The more calories you burn.
More calories I'm gonna burn, right? Okay, that should be way enough to get you started, right? I think you guys probably should be able to finish the rest of that paratech and then move on to the worksheet. Yes? Okay. Don't forget, you guys need to go back and do your what? Go back and check your mastery box. Anybody a 2? Anybody a 1? How about a 0? How many 3s do we have? Raise my pie. Raise my pie. How many 4s do we have? Okay, I'm gonna be calling on my 4s now.